Hello students, we are meeting for our next lecture of cement and glass industry, and up till now we have discussed the proportionating of raw material. Now we'll see actual manufacturing of cement, and it starts with the preparation of kiln field. Here kiln feed means before uh, is supplying the raw material to the kiln, okay, where heating process takes place. Before that, it should be properly treated. That is called as preparation of kiln feed. In that, grinding is extremely important in preparing raw material mixture for filling to the kiln. The preparation of the feed normally carried out by two process, that is wet process and dry process. That both the process will see in detail. Before that, we should know why, in which condition the wet process or dry process to be selected. And wet process is not used nowadays because it takes a higher it requires higher thermal energy to evaporate the water added. Still, in certain conditions, the wet process is also used. The wet process is used when the raw material, if you see the physical condition of raw material, the local factory climate condition and price of fuel, the wet process is selected. Means here, if the raw material is soft and climate is fairly moist, then wet process is used. Otherwise, dry process is most favorable step. So we'll discuss the dry process, which is called as modern process. So in the dry process, the raw materials are roughly crushed, and it is followed by powdering in hammer mill. The block diagram is like this. So here you can see the it is first the raw material is roughly crushed, and then it is powdered in hammer mill. Then the materials are dried in rotary dryers. Okay, so rotary dryers help to dry the starting material, and it is proportioned and more finely ground in tube mills. Okay, after proportionating, they are sent for the tube mills for grinding. Then their air separator is there, and then the product thus obtained after this is known as raw mill. It is fed to directly to the rotary kiln for production of clinkers. The various operations are as indicated in the block diagram. The dry process kiln are short. uh, the dry process kiln means here, when we'll discuss see the diagram for rotary kiln, the length of that rotary rotating tunnel is less, or you can say short, if it is a dry process. And if it is a wet process, then surely the length will be more, because it takes time to get dry. So wet process requires a long tunnel as well as more thermal energy. The dry process is used where hard crystalline limestone, slates, and natural rock cement are found in plenty. Okay, so whenever it is a very crystalline, or you can say hard kind of raw material is there, then dry process is useful. If it is not so, means uh, if the it is soft and the atmosphere or the local, you can say, climate is moist, then wet process is preferred. So in this process, water is added to the material while grinding to form the slurry. Means because of addition of water, after grinding it forms the slurry, and this slurry is passed through bowl, classifier, and screens. So limestone and shells are hard and hence crushed separately and fed to large tube mills. The slurry is pumped to correcting tank, where it is agitated and proportion to desired composition. So this slurry is then filtered and reduce the water content to 32 to 45%, and it is called as raw slurry. The slurry is then passed to kiln feed tank if equipped with agitators. Means this slurry after removing the water up to 30 to 32 to 45%, then directly fed to the kiln. Okay, so before going for the process, what process is taking place in the kiln, we must know one very important process, that is a beneficiation process, which is carried out by flotation. So, what is beneficiation? So, it is common practice to upgrade the raw material in the desired constituent. One such method commonly used in cemetery industries, flotation process. Means here the argillaceous and siliceous materials, its concentration is increased by flotation process, and that is called as dressing of ore. Now this beneficiation is carried out in two ways. The one is, you can say, anodic cell, that is a fatty acid flotation cell. So in this fatty acid flotation cell, oleic acid or soap or frothing agent like synthetic alcohol is used. The raw materials are ground to pass through 100 mesh filter. It is then added to the flotation cells. Okay, so as the froth is produced by bubbling air, the calcite grain in our raw material get attached to the bubble of the froth and rise to the surface. Okay, and means here the calcite grains are in the overflow. Okay, they get overflow. The quartz, mica, feldspar, these are hard siliceous material. Other grains get wet and they do not float, and they are continuously discharged from bottom. Means they settle down and they are removed from the bottom. Thus, the overflowing froth contains higher percentage of lime, while underflowing material contains lower percentage of lime and higher percentage of micaceous material. Okay, so this is a fatty acid flotation cell. Then next is cationic flotation cell. It contains cationic reagent, that is a hydrochloride salt of lauryl amine. Okay, so this reagent, when added to the slurry of ground raw material, the silicates of aluminium and magnesium combine with it and float on the surface, while ferric oxide quartz get removed as underflow. Means here the siliceous material, which is acidic in nature, reacts with our basic reagent, that is lauryl amine, whereas the oxides of say iron, that is ferric oxide or quartz, get removed as underflow. So the overflowing froth contains higher percentage of micaceous material, while the underflowing material contains higher percentage of lime. Means lime and siliceous materials, they are separated by either by fatty acid flotation cell method or cationic flotation cell. Okay, so the procedure of flotation may change as per the requirement of raw material for producing different types of cement. Means here the percentage, as we are discussing classification, goes on changing depending on the different types of cement. So here, depending on the constituents, different percentage are given. So as per requirement, the fatty acid flotation cell or cationic flotation cell method is used. Now we'll move ahead to the actual burning operation. Now means up till now we have seen the proportioning of the raw material, then preparation of the raw material, that is for the kiln feed, and then beneficiation flotation. Then first we'll discuss the actual burning operation, which is a very important step of the manufacture of the this cement. So this is there are two types. The burning operation can be carried out in kiln, and there are two types of kiln. One is rotary kiln. The diagram is like this. You can see here the rotary kiln is long cylindrical furnace. The long cylindrical furnace you can see here. This is the main part of this long cylindrical furnace. Okay, it is made up of steel and it is lined inside with the fire brick. So for wet process, this just now we discussed the wet and dry process. This is the actual length of that uh, rotary kiln, and that is the cylindrical furnace. So this rotary kiln, the cylindrical furnace, its length depend on whether we are going to feed the raw material by wet process or dry process. If it is a wet process, the length of this cylinder becomes 90 to 170 meter, whereas if it is a dry process, then 50-meter length is sufficient. So it is, and one more thing you can see, it is slightly kept at inclined position. It is not horizontal or vertical, it is a slightly inclined. Okay, so here why is it so that when this cylindrical part of the furnace rotates slowly, that the material moves ahead. Okay, so so after the rotation speed of this cylinder is either half rotation per minute to two rotations per minute, means within a or it can rotate 30 times or 60 times. Okay, so due to inclined position, what happens, the charge slowly travels downward toward the hot end of the cylinder. The kiln is heated usually by a blast of powdered coal and air. See, you can see here the coal dust is supplied here, and this is the flame you can see here. Okay, so the kiln is heated usually by blast of powdered coal and air. So here there is a flame, and as you can see, this comparatively the starting point end is cooler than the end point. End point is very hottest. So from left to right, you can see the temperature goes on increasing. So the highest temperature toward the lower end of the kiln is observed. So as the charge moves from left to right, it proceeds toward hotter zone. The maximum temperature you can see at the end is 1400 to 1600 degrees Celsius. So heat from gases come out from the upper end of the kiln is recovered by passing the gases through waste heat boiler, or heat is used to heat the other gas or to preheat the raw material. Means this you can say these gases here, it is very hot. As it you move here, that becomes cooler, but these hot gases, they will pass through this settling chamber further, so that it can be recycled, so that their energy can be recycled. Okay, and there is another actually what operations are taking place here, that is a main process that we have to understand from chemistry point of view, but that we'll discuss afterwards. First we'll just try to know the two types of kiln. One is a rotary kiln, and wherever there is a large quantity or large production of cement is there, this rotary kiln is observed. Okay, and there is one more is there, that is a modern vertical shaft kiln. Okay, and this is used for small scale manufacture, and in vertical shaft kiln, uh, the process which is used, that is a black mill process. Means black mill process means here uh, the raw material, that is a siliceous and argillaceous material, is mixed with the fuel, that is a coal. So they are together, they are ground, that is a limestone, clay, and this fuel material, they are grounded together to about 15 millimeter mesh size, and all this material is subjected to grind to in a ball mill and roller mill. So homogenizing means proper mixing, so that no one will be separated out. So this homogeneous mixture is formed, and then it is nodulized. Okay, means small balls are formed. So successful operation of vertical shaft kiln depends on to greater extent upon the size of this nodule. Okay, So their uniformity, porosity, and thermal stability, all these things are depend on the how that nodules are formed. So the diagram is like this. You can see here. This is the main diagram you can see, and here if you see the cursor from this top to this part is the main vertical shaft of the kiln, where this material is charged from this end. Okay, you can see here. Hmm? And the effluent gases are coming out. You sometimes rotary. So these are the different parts of that rotary kiln, but this is a vertical shaft. Why it is? Because this small part is continuously rotating. So rotary grater you can see. So the vertically they are spread. Slowly this material is uh, get charged or dip, you can say collected in this chamber, cylindrical chamber, which is poured through conical shape inlet, and then further process, whatever heating process takes place actually in this part. Okay, and that too at the different temperature. So rotation is here. You can see this is a rotatory grate. After hitting the rotatory grate separates this final product. Okay. So the clinker finally extracted from kiln bottom through the gamma. So uh, uh, this vertical shaft kiln is a modern vertical shaft kiln in which the nodules are converted into clinker. That is the main process. Okay, and it consists of cylindrical shell that just now I shown with the conical portion at the top, which is lined with the refractory bricks. The sintering is normally completed within the conical portion, which is specially designed to allow shrinking of nodules. Means slowly when the material start burning, the nodules get shrink. The various zones of reactions starting from top of the kiln are the drying zone, the calcining zone, the sintering zone, and cooling zone. You can see here. Okay, starting from top at different temperature, different types of different reactions are taking place. Okay, the whole kiln charge composed of nodules, clinkers, rest on the specially designed flat grate rotating slowly at the bottom of the kiln, mounted over the kiln shaft. See here, when this is rotating at the same time, after the product gets distributed using this rotatory grate, it continuously rotates. The grate is driven with the help of variable speed motor in order to control the discharge of the rate of the clinker. Means through this rotatory grate, clinkers are discharged. The clinker is finally extracted from the kiln bottom through a gamma ray controlled material block tube. Okay, so this material block tube is this one. Okay, so that is controlled by uh, uh, gamma rays. Okay, and the modern vertical shaft is based on small cement uh, plant. Okay, it is shown over here. So number of processes have been used, but they all use the same vertical shaft kiln and differ only in procedure of method of feed of preparation, or wetting the coal particles, or adding the fuel in steps, and so on. So these are the various. So but what are the applications, what is the difference, and how vertical shaft kiln is more advantageous? Low air, first is low air pollution due to low velocity of exit gases. Okay, so no water pollution, as no effluent involved in the process. That is the first thing. Then second is lower maintenance cost. There is no very less maintenance. Higher refractory life. This life of the kiln is more. Possibility of temperature shutdowns up to 48 hours without applicable loss of heat and material in the process. So this shutdown of electricity also does not harm the process. Low cost investment. Okay, means almost two times lesser than the rotary kiln, and no much skill is required to operate the vertical shaft kiln. So here, by two process, that is rotatory kiln or vertical shaft kiln, is used for the heating process, so that the raw material is converted to the clinker. Now, actually, how the clinker formation takes place, that is the matter of very important. Okay. So, as the kiln, we are going to discuss the clinker formation, especially for the large scale production of cement, that is using rotatory kiln. So, as the kiln this rotate, the charge slowly passes through different zones to reach the other end of the furnace. So, for following the changes which are taking place are as follows. First is a drying zone. So, in drying zone, what happens? Uh, uh, Water is driven out of the slurry by means of hot gases. Okay, this is also called as water evaporation zone. That is called as drying zone, and it is the upper portion. That is the, you have seen that cylindrical part, the upper one fourth part of the that cylinder. Okay, the temperature of this zone is 750 degrees Celsius, and the free water from slurry is driven off at 100 degree Celsius. Okay, and at 500 degrees Celsius and above, there is evaporation of combined water from clay. Means here, the water which makes wet this raw material is removed at 100 degrees Celsius, but the water of crystallization kind of water is removed at 500 degrees Celsius. So if there is iron hydroxide is there, that will be converted to ferric oxide. If it is, you can say, water of crystallization for alumina and aluminum silicate, then that is also removed. So the reactions are taking place, which are taking place at this 450 and 600 degrees Celsius are like this. Then the charge moves ahead to still hotter zone, which is at the 900 degrees Celsius, or you can say 1000 degrees Celsius, and this zone is called as calcining zone or decomposition zone. Means here the lime, that is calcium carbonate, get decomposed and carbon dioxide get removed. It can be calcium carbonate or magnesium carbonate. So in this zone, the temperature at temperature of 1000 degrees Celsius, organic matter first of all burns away, and it decomposes the limestone and dolomite, that is magnesium carbonate, and the reaction is like this. Very common calcining zone means removal of carbon dioxide. So about decarbonation, this reaction is endothermic, which requires the temperature. So chloride and alkali salts are partially volatilized, and a portion of sulfate is decomposed, liberating sulfur. Okay, then slowly the charge moves ahead where actually main reaction takes place, that is called as hottest zone or sintering zone. Okay, so in this sintering zone, it is also called as cement forming zone. Here actually the desired reaction takes place. So in this zone, the temperature is about 1400 degrees Celsius, and here about 20 to 30% of material undergoes melting. And slowly here, melting process start to take place, and the melt reacts with surrounding particle, and sintering takes place. Okay, means actually sintering is combining of siliceous and lime material. Okay, so in different proportion this sintering takes place. So lime reacts with the clay to form calcium silicate and aluminate. So sintering takes place in this zone, and material form is known as clinker. Means there are two important raw materials at the beginning of this chapter I told you, that is lime and silica. Okay, and these two they combine at this hottest zone in different proportion to undergo different reactions as shown here. Means here C2S, C3S, C3A, C4AF, they all get combined to form these compounds, and the reactions are as shown here. So due to these combustible and volatile products, About one third of original weight of dry mixture is lost in the burning process. Obviously, water is lost, carbon dioxide is lost. So obviously, one third weight get lost in this heating process. And the nature of reaction taking place in different zones are like this. That is drying zone, calcining zone, and hot zone. So all these processes which are taking place in the kiln at different zones, they are indicated in this chart. You can see at 100 degrees Celsius evaporation of water, drying zone, 500 and above evolution of water from clay, that is in the same drying zone, the water of crystallization get removed. Then 9 at 900 to 1000 decomposition of lime takes place or dolomite take place, and that there is a evolution of carbon dioxide, and at about more than this temperature, reaction between lime and clay takes place, and slowly this liquid first it melts, and then further these get combined at about you can say 1400 degrees Celsius to form the clinker. Okay, and all these processes are endothermic except one, that is the calcination of dolomite. Okay, or lime, where this carbon dioxide is released. So this is the actual main process where cement is formed. Now, what is the product of this burning process? That is a clinker. Okay, so what is the clinker? Clinkers are the small round balls with greenish black or gray color discharged from the rotary kiln. Okay, now what to do with this clinker? Means how we get the powdered form of the cement. So the next process is a treatment of clinker. First process is cooling. Now in the rotary cooler, a rotary cooler is the rotating steel shell fitted with baffles. Baffles means in between there are some you can say blades are there, which continuously make ups and down of this rotating clinker, which lift and drop the clinker to effect the cooling. Okay, means they lift in while rotating and again drop. So during that lifting and dropping, clinker get cooled. So heat loss from the clinker is recovered and used for many purposes in the manufacture. So rate of cooling is controlled to avoid complete crystallization of the clinker. Means here cooling is controlled. The rate of cooling is controlled. Otherwise, it will form the crystallization of crystal product. So incomplete crystallization has been found to be advantageous when we don't want the complete crystallization. So the cooling air blows at the top of the dust from the clinker. Okay, so this cannot be allowed to escape in the atmosphere, which may cause air pollution. Okay, so the dust is trapped in a setting chamber, which is returned to the kiln. This is setting chamber is there at the beginning of the kiln. The next step is addition of retarders. What to retard? Okay, so we'll see here as the clinker passes to grinding mill, it is mixed with the proper amount of retarders like gypsum. Means what this gypsum retards? Okay, the retarders are negative catalysts that controls or slow down the time of setting of cement. It also avoids the undue rapid setting or stiffening of concrete. The addition of 1% of talc improves the grinding efficiency by 6%. So that is the retarder, which avoids the setting of cement. Means it increases the time for setting. It slows down that process. The next is grinding and packaging. The clinkers contain gypsum and other additives is ground finely to specific size depending on our requirement, and that is grinded in the ball mill. The finely ground cement is then passed through the air classifier to the cement storage silos. Okay, and the last one is storage and packing of cement. The ground cement is usually stored uh, in concrete silos and packed in jute gunny bags. Storing of cement for some time before packaging is beneficial. Okay. Prolonged storage of cement in packages, especially in moist air, decreases the strength of cement due to partial hydration and formation of coarse particles. So that is very important. So this is the storage and packing of the cement. So there are special types of cements also. That is, first is Bassett process, Portland cement and pig iron. So the raw material limestone, that is calcium carbonate, coke and iron ore, are burnt in rotary kiln. So in the burning zone, molten iron is collected, from which pig iron is taken out separately. So that is the byproduct of this Bassett process. The clinker is allowed to pass to the other end of the kiln and to the cooler. During this process, reducing atmosphere is maintained in the kiln. Okay, there is no allowed oxidation. So in this way, along with Portland cement, pig iron is obtained. Means due to reducing atmosphere, this iron does not get oxidized. So we get the side product of the pig iron. Then sealers process, that is Portland cement and alumina. The raw material contains limestone, siliceous bauxite clay, which is rich in alumina. You can say it is a ore of alumina and slags etc. So proper proportion of mixture is burnt in the rotary kiln in normal way as we discussed. And the product is treated with sodium carbonate solution to dissolve alumina. Okay. And the solid residue is then mixed with additional limestone and reburnt to give cement clinker. Alumina is recovered from the extract solution as the byproduct. So this is uh, you can say another byproduct of the cement. Then next is Duker and West process, port and sulfuric acid. So the raw material contains calcium sulfate, that is anhydrous gypsum, clay and coke together with sand and iron oxide. This mixture is burnt in rotary kiln when sulfur dioxide is produced from calcium sulfate, and it is used to produce sulfuric acid as byproduct. Means this is the third important byproduct, that is sulfuric acid can be obtained from sulfur dioxide gas and may be further converted into fertilizer grade ammonium sulfate. So cement clinker is formed by reaction of liberated lime and alumina, silica and iron oxide. So the Portland cement is produced from the clinker. So here how sulfuric acid is obtained, that reactions are like this. Okay, means for the gypsum, calcium sulfate convert to calcium sulfide. Again, the process goes on, and at the end, the sulfur dioxide is released, which is when treated with water convert to sulfuric acid. So, these are the various byproducts which are obtained. Then at the end, there are uses of cement. All of you know what are the uses of cement that you can write. Only the thing, it is a matter of curiosity that the material, that is cement, we get when you go in the market and purchase, that is in the powder form, and how it is get converted to such a very strong material so that a large infrastructure constructions can be made, and that comes under setting and hardening of cement, that we'll discuss next time. For timing, we'll stop here. Thank you.